Do you understand exponential growth? Let's take a look at a real-world example. Carmen is selling candy bars. Every day, she goes door to door selling them. On the first day, she sells 4 candy bars. On the second day, she sells 16. On the third day, she sells 64. Based on this pattern, how many is Carmen going to sell on the 4th day? This example is an example that uses exponential growth. Let's look at what happens with the number of candy bars. When we go from 4 to 16, the number of candy bars sold on the first day is squared. When we go to 64, the number of candy bars sold from the first day to the third day is cubed. If our candy bar sales follow this pattern, then from the first day to the 4th day would be 4 to the 4th power. We can write a function to show this. We can write the function y is equal to 4 to the x power. What does that mean? Well, let's look at our data in a table. If we put x here and y here, we can say that on the first day, 4 to the 1st power, Carmen sold 4 candy bars. On the second day, 4 to the 2nd power, she sold 16. On the third day, 4 to the 3rd power, she sold 64. And if we follow this pattern, on the 4th day, Carmen will sell 4 to the 4th power candy bars, which will be 256. What if she had sold 5 candy bars, but we were still using this basic function? We would have y equals 5 to the x power. Let's take a look at what that would do. We have x and y. On the first day, 5 to the 1st power, she would have sold 5 candy bars. On the second day, she would have sold 5 squared, 25 candy bars. On the third day, she would have sold 125 candy bars. And following this pattern, on the 4th day, she would have sold 625 candy bars. Now, exponential functions that represent exponential growth can be shown in a graph too. Let's look at what a graph would look like that represents exponential growth. This graph shows exponential growth in hours concerning the number of bacteria that grew. You can see that the graph for an exponential growth function is curved. It's not linear. It forms this kind of a curve because the data is growing exponentially. Here's another one that shows how a population changes over time. Again, notice the curve. When you see a curve upward like this one that goes from the left to the right, and in this upward motion, here we go, let's do this here, you know that the function is an exponential growth function.